A very good evening to all, respected dignitaries. Am I audible?
Yes, ma'am.
Okay. So, respected
Yes.
dignitaries, resource persons, faculty members, and participants, on behalf of Department of Computer Science, Nirmala College, Muattivira, I warmly welcome you all to the Day 2 sessions of FDP on Advances in AI. Today, we will be having our first session on prediction using effective computing, techniques, applications, and ethical implications by Dr. Tamil Selvi Palanichami, followed by an interactive session and Q&A. Later, we will be having our second session on Introduction to Spatial Computing and its applications by Dr. A.C. Shandashila. We request all the participants to kindly remain engaged and use their chat box or raise their hands for queries. Participants, please note, attendance is mandatory for all the sessions. You will be getting a feedback form prior to every sessions. Kindly fill it. I invite Tini Tampan, Assistant Professor, for welcoming the guest speaker for the first session. Over to you, Tini ma'am.
Good evening, all. Dr. Tamiselvi Palanichami. She's a professor in the Department of Computer Science and Business Systems at Rajalakshmi Engineering College, an autonomous institution in Chennai. She was awarded a PhD in the domain of natural language processing, applying machine learning techniques from Satyabama University, Chennai. With over 26 years of teaching experience in reputed institutions such as KLN Engineering College, Jeppia, Jain deemed to be University, Bangalore, and now in Rajalakshmi Engineering College, Chennai. Dr. Tamishelvi also possesses more than 20 years of research experience spanning machine learning, deep learning, natural language processing, data visualization, AR, VR, and quantum computing. She has published more than 60 research papers in various journals and conferences, holding an H index of 6 and an Item index of 4, and has received Best Paper awards on both national and international conferences. She has delivered more than 20 workshops and seminars on Python, MATLAB, machine learning, deep learning, artificial intelligence, image processing, computer vision, AR, VR, and quantum computing. In addition to her academic and research accomplishments, she has 3 patents that have been published. On behalf of Nirmala Fraternity, we welcome you, ma'am.
Yes. Thank you so much, ma'am. Actually, it's my pleasure to thank all the high-level management, principal, HOD, and all the dynamic coordinators who are organizing this Atal FDP and inviting me to talk about the topic of prediction using effective computing, and in that technique, applications and ethical implications. I hope I'm audible.
Yes, ma'am.
Yes, ma'am. So I will share my screen.
Okay, ma'am.
Okay, ma'am.
So this is about today's topic, prediction. Now, machine learning is mainly used for doing predictions. You are all working on it. I think almost ML, statistical based ML, it is having a feel of getting outdated. Now the DL is dominant. This actually, the effective computing is done both by using machine learning as well as deep learning. But machine learning, when you are going for feature extraction, it will be little complicated than the deep learning. So here the best choice for doing the affective process or affective is nothing but emotion. Affect means emotion only they are focusing. So when we are trying to make the prediction based on the emotions, then we are calling that as an effective computing. And here the deep learning is dominant. So with respect to that, what are all the various modalities? Modalities means various sources or various places where we can collect our input for measuring the emotions. That we are going to see. Then after that, we are going to see the basic technique, how we can make the prediction. because we have a difference between deduction and prediction. So that we are going to see next. Then after that, applications, the basic level of applications I'm trying to say here, and it is purely based on the way how we are going to extend. So this is the agenda of today's session. We are going to see the introduction, next techniques and models. What are all the various models we can use for the effective prediction, along with the modalities we are going to see that. Then main applications, ethical, privacy, and bias. Why here the ethical message it is important, or ethical that is issues are majorly we need to take care, means the emotions are purely involving into a personal thing. So when we are dealing with, or we are trying to predict a person's that is the next action, that is the prediction. So these are all the sequential actions of a person we have observed. So what he will do next, that is going to be the prediction. So when we are going to work on the personal thing of a person, then ethical concept is main role. So because of that only we are talking about the ethical need of that is effectiveness. Then future direction. After that, demo, and in the demo I have taken only the deduction level, because if at all we are going for prediction, the sequential task we need to collect. Then on the data, the historical sequential collected data, we need to apply, and we have to go for prediction. But anyway, I'll give a way how we can do it. So that demo may be helpful for you. So what is the basic effective computing? It is actually builds machines that sense, understand, respond to, and influence the human emotion. So now it is having the capability of influencing the nature of the human. So we are observing continuously, and we are trying to predict how he is going to be next, and we want to make some kind of changes. Then we can go with making the proper what are all the additional things we need to make to change the current situation or current environmental factors which are going to make him to the immediate next, maybe like hyper, or maybe to the downward, whatever it may be. So now the next change, if it is not actually up to that expected level, and he can go in some other direction, means then we need to go for changing the environmental factor along with all other supporting factors. So that may be the recommendation for the person. So that is effective, means we are going to make a deduction. Then from that we are going to make a prediction. Then if at all he is having or expected to be in that situation, and we are not interested to go into that situation. For example, a student, he is actually doing or attending the class. The class duration is 1 hour. Usually we are watching from the beginning for 15 minutes. He will be very attentive. He will start that is writing everything. But after 15 minutes, slightly he will get diverted or disturbed. Then that should not be happen. He has to bring back to his original state. So that means then some kind of that is environmental factor. Maybe a message can be sent to his or her mother. Please actually make a note whether he is getting diverted, or if he is actually if some kind of diversion if we are giving, he may come back, means we have to observe. So what kind of situation will make him to bring to the previous situation, that we need to observe, and then we need to go for the next step. And these things are actually the effective computing will help us to go for making a better decision. This is in an educational side. When we are getting into the medical side, it is like a miracle. For example, one person, he is affected with some kind of chronic disease, and we are not going to ask whether you feel better than that is last visit. Just we are going to capture the that is the face and the facial expression, everything through the camera, and from that we can identify whether he is better than yesterday's situation. The facial reaction will give us 100% accurate information about his feel. So no need to go and ask. And these are all the advanced technique we can apply or incorporate to, that is, instead of asking, then we can decide what kind of treatment we can give, in what are all the ways he can get into or he can improve. So which way he is getting improved or which way he is going down, those things we may get analyzed and we can go for. So these are all the basic that is recommendations we can do with the support of the emotional content. And this system engage in bidirectional emotional interaction. And this bidirectional interaction, it is telling about in both way the communication. It is like a conversational system. So to whom he wants to convey, that person or that system will, excuse me, that system will also will try to give some information, or it will try to comfort him, or it will try to improve him. Whatever he needs, that will be given by the opponent. So that is actually the bidirectional emotional interaction. It is not only in detecting the effect, that is, it is not only to identify the emotion, but also modulating it through adaptive behavior. So we are observing the behavior and we are trying to that is fine tune in what are all the ways we want to regulate it. And that is the major achievement in that affective computing. And first, I think I want to say one thing. From where I got impressed about this one means through NPTEL, while doing my AI domain certification. This is one of my paper, and I got very much impressed. And the way how they have taken it is, with respect to me, it was very interesting. It was so useful. And even the students now, they started to focus on doing their projects towards this. So this point I want to convey. All actually the inspiration, it is from NPTEL affective computing course only. And here the affective sensing, it refers to the ability of the system to detect and recognize emotions. So now the main thing, we have to identify in what sense or what actually emotion, then we have to recognize what it is going to be. Analyzing data from various signals and patterns. So if we are collecting the data from one channel, will be okay, but will it be sufficient means not sufficient. So we need to go for collecting the information, the emotional information from various channel or various modalities. They are using the word modality here. To achieve this, the system requires both appropriate hardware and software. So definitely, if you want to observe the facial expression or voice information, then the proper hardware configuration, the high level configuration with very less noise configured hardware we need, and software, definitely the fast processing software components and all we need. And affect sensing systems are often categorized based on modalities. So modalities are nothing but the various modes through which we are collecting the different affect emotion information. That is actually important here. The next one is emotion recognition and emotion prediction. I think I started from this only. Emotion recognition means when we are analyzing an image, then from the current image, we are trying to find whether the person is looking happy or sad or neutral, like that. And here we are categorizing as per our convenience. And there is no specific categories, only fear, angry, like that. And there is no specific limit for that. And we can make a category as per our convenience. So this is with respect to one data. If we are trying to find the emotion, we are calling that as a recognition. And this is not sufficient because for that image alone, we are making that actually in what state it is. But when we are going to prediction, then continuously we have to observe that object and we have to record in what way that is the time frequency also much important. And if he is feeling happy means, then we have to see and in what situation, surroundings, everything it is actually matters, and the environmental factors and his health condition, everything matters. So in which are all the situation he feels happy, and in which situation that actually making him to get into the sad situation, and these things should be observed continuously. And for a certain while we need to collect the data, then we can consider that collected data as a training set. Then based on that, we can train our model then the current situation, if he is looking good, or we are trying to capture the various modality signals, then if the signal will be processed, then the historical data based on that, his situation or how he is going to be, or in future, that is after this condition, and how he will be. Now he is happy, and after that he will be normal or hyper, or whether he will be getting into the anxiety. So those conditions, or the based on the current situation, what will be his next state, that can be predicted. And for making the prediction, we have to collect the emotional recognition continuously from the object, which object we are interested. Then various modalities, already I said, it is different channels or sources through which we are going to collect the emotional states. And it can be either we can collect in a form of that is without touching or without disturbing the object, we can collect, or through some devices which can actually keep on the object, like IoT, and from there we can collect the information. So multiple sources are there for collecting the data, and each modality captures a unique, so each and every modality, they will give their own data, and there is no repetition among themselves. And here one will give the physiological information, the next one may give the behavioral information, then contextual information, like that. And we can take those information separately, or we can combine them and we can make a model. So now these are all the various sources we can. Now we are going to see one by one. The first one is a facial expression. And here the signals. Signals are actually taken, here the signals will be considered as an action units or AUs. And the AUs are telling about the what emotion they are. And all these are all micro expressions. So on the face, we are not going to take the general expression. We are going down to that actually. We are going depth to that facial expressions, and we are going to fetch the data. And even the head pose, how they are keeping their head, and the eye, that is the gaze, eye, how they are actually, whether they are opening large or they are keeping their eyes closed, and how their eyebrows, everything we are going to. So that is gaze direction. And these are all, here you can see AU1, you can see that eyebrow, it is going up, and eyes are very large. And these pose we are calling that is the researcher, they called it as an AU1, or it is nothing but the action unit 1. And when we have these kind of that is a facial feature, then we are calling that as like a happier, like that. So now here they have categorized AUs. If AU is going to be 1, then it is like a fearful. I said it is happy. Happy is like this. So now that eye opening, you can see the difference. It is like it's external, it is like internal, and light difference. So this is the drawback mainly with respect to the facial expression, because when we are focusing on the points, the same point will try to support multiple expression. And people, that is while doing their research, they felt very difficult whether this kind of eye opening, should I consider it as a anger, or should I consider it as like fear or happy? In what situation should I? And to overcome this later, people, they started to combine multiple modality signals. Okay. And here the sensors, RGB, IR cameras, through that we can capture the images. And depth sensor, if at all possible, we can go with, and that will give our features in a clear way. And the main strength, it is high social, that is, we without disturbing the human object, we can take. That is the main strength, and that is going to be the main weakness, because we cannot take the human information without their consent. So that is another important thing here. And rich in discrete emotion cues. So now here, Ekman, he is one of the person, he did enormous research on the affect computing, and all the emotions here, it is considered as a discrete one. So limited number of classes. Classes means category. So anger is one emotion. Happy is another emotion. Fear is another emotion. Like that, we can make a discrete kind of emotions. And all these are all limited number of emotion. That is the main strength. And what limitations we are having in this means affected by lightning. So if the face is getting enough light, then the features capturing will be good enough. Suppose if the light is not good, or otherwise the person he turn his head towards the dark side, and the camera couldn't able to capture his image in a clear way, then that is we couldn't expect the better result over there. That is the main drawback. We are depending the external factor, and which is not going to be part of it. But that is playing a vital role, because that will affect our feature extraction strength. Occlusion is the way how we are observing the content. And cultural display rules. And some people, that is cultural means when we are going to take a group photo, and without their knowledge, if at all we are trying to capture, out of all this, if one or two, if they have observed, somebody is capturing the photo of that group, they may hide their face. So from one object, we are missing the information. Why I'm saying, in the group, and we can take individual, that is emotion or affect, then finally we can conclude in that group whether they are in a happy situation, or in a sad situation, or in an angry situation. So that conclusion will be missing. Because of one or two objects, they may hide their faces. So all these are all cultural display rules. And the voluntary masking, this is the set I said, no, they can mask their, they can hide their face. And the cultural display rules means we may have set of rules. These things should not be captured, and those things should not be captured. So these are all, there is no very hard and defined rules for this. And based on the environment, based on the geographical situation, based on the geographical representation, their customs, that things will be getting differed. In some situation or in some places, they will never mind. Whatever you are doing, okay, let it do, we never mind. If you are getting into the rural place, and they will never, some people, they will never allow for taking the photograph. Even those days, that is the ancestors, they will never have a habit of taking photos, because they had a thought of it will affect their long living duration. So those things are their faith, and that we cannot disturb. And so in that situation, we cannot force them also. So these are all the drawbacks. So the limitations are not only with respect to the lighting and all, the customs also, it's one of the major important things. So now here the happy and AU6, it is telling about the happy, and AU6 means under this I we have a point. So many points will be taken collectively. Here we have all the points, and all the points will not be taken for doing a process of one, if that is emotion, and very few points which are all collectively taken, and based on their distance, and it will be measured, or it will be identified whether they are in a happy mood or not. Okay. So now this is about one modality. That modality is a facial expression, and this alone we can take, but this is not sufficient, because we have seen so many limitations. So due to this limitations, this alone, if at all we are sticking with that to identify or to predict a person's emotion, it is not going to be the best. So we are in future, we can combine multiple modalities. So next modality, what we are going to see means vocal. So that is like a sound. And here it is going to say about the pitch, the intensity. So in what pitch we are, frequency, intensity, how depth we are actually, and speech rate, how fast we are doing our delivery or speech, and each and every rhythmic information that will be considered as a signal for identifying the emotions through the vocal signal. And here, which are all the sensors are used for doing or observing means microphones, audio interfaces. And the main strength of this one, what are all the main strength means, it is capturing arousal and balance well. So now here it is getting the two different extreme information. When we are shouting at the peak, it will be like observed very clearly. And if we are very soft, and that will be, and in the medium, if we are, then it will be little bit some modulation will be it will make us to make a classification. So at the peak, okay, maybe in anger or in maybe high happiness, that is excitement. And the next one, it is the next emotion, it is going to be fear or sadness. That is the lowest end. Then between that and all other emotions we can place. Okay, that is, and it works without a visual line of sight. So here we don't have any visual thing, only the frequency waves we will use for doing the process. And main limitation, when we are talking about the sound or that is vocal information, definitely the surrounding noise will be added into that. So that we cannot avoid, and that is dominant here. And that is one of the major drawback. First, we have to go for removing the noise or suppressing the noise. So totally we cannot remove, but we can think of suppressing the noise. That we can do. Then language accent dependency. So here the language is much important, and the way how we are delivering and the accent will help to make the signal to reach, because whatever we are trying to give, that is mainly to give our emotion. Okay, so while we are talking about the emotion, the language, how we are, whether we are talking fast, the same language, one person, if he is talking very fast and we couldn't able to identify whether he is normal or abnormal, happy or sad, it is difficult. And the way how he is talking is going to be comfortable, not very slow, not very high, and he is talking in a medium way, then that may help us to observe his emotion. So that the language and its accent are much important. The next one is acted versus spontaneous. Here, this is much important. Acted is elicited. So we can that is elicitation means forcefully we can induce him to make such a sound. That is like acted. We are making that person to do. Spontaneous, without anybody's external force, if he is doing that action, then it is real. So that data is much valid than making him to react. So that kind of original data, observing that is a challenge one here. And speech mismatch. And this is another important one. He may try to convey one content, but it may reach the audience in another way. So these kind of mismatches will lead into the different emotional reduction. So these are all the second type of signal that will help to observe the emotion. And here actually in IIT Kharagpur, they are doing a research, because this paper was handled by them only. And these two are the speech-based data set. And the first one is Telugu-based data set. The second one, it is Hindi-based data set. And these two are used for doing the vocal-based research analysis for emotion reduction. Okay, then aroustic features. Here, loudness. Here, this is what it measures. So when we are the sound, the volume, it is telling about the signal energy amplitude. So when we are talking about the signal, and it tell about its amplitude, how far it is going to be. So now when this is very high, then that loudness is high, it may represent the anger or it may represent excitement. If it is very less, the loudness level is less, it may represent the sadness or even the fear. So here also we are having either this or that. The clarity of actually the emotion is not clear. So when we are combining multiple modalities, that confusion may be cleared. The next one, pitch. Pitch is actually the frequent and the fundamental frequency. And if it is the frequency is high, then that emotion is actually categorized as surprise, or otherwise it can be considered as fear. If it is down, then it is boredom. So now when that the frequency is going down slow, then it is representing the boredom situation or even the sad. Okay. The next one is vocal tract resonance, and it is again F1, F2 frequency level. And F1 if it is down, then F2 if it is high, and these two combination tells about the happiness. F1 is high and F2 is down, then this two combination tells about either anger or disgust. So now these way, the frequency alone we can combine, or we can, that is, these are all the various frequencies we can extract from the vocal signal, and from that actually we can go for finding various emotions and speech rate and how far we are delivering our content, the speed. So how many words we are delivering within a second, like that. And if the number of words delivered in a second is very high, then the person is not normal. He is looking little excited, or he can be considered in an anxiety situation. If the number of words coming out per second is very less, then we can say he is not normal. He is looking very sad or even fatigued. He is not in a out of mood. Okay. And the spectral, that is energy, it is like a frequency balance. Am I in the line?
Yes, ma'am.
Yes, ma'am.
Audible. Yes.
Yeah, thank you so much. So frequency balance, it is telling about high, mid energy. So now the energy starts with high, then it's coming down to mid, then it is telling about the anger. And low energy, if it is looking low, then it is telling about the depression. So now these are all the various that is vocal frequency or vocal features we can extract from the audio signals for identifying the emotions of a person. Then this is one second modality. The third modality, and in the first two, we have never disturbed any person. We have never touched anyone. So through the distance, we try to observe his face and voice. So external device we used, and that external device observed his face and voice. And the third modality, it is physiological signal. Here, totally we are going to depend on the sensors. So some kind of sensors that will be kept on the physical body of a person, and that is going to observe the content. From that, we are trying to identify the emotion of a person. So the first one, it includes multiple submodalities. Electrodermal, the dermal, it is telling about the skin-based emotions. And here EDA or GSR, and these two are mainly used for measures the skin conductance. So now the skin-based, that is emotion detection. If a person is not good, and if he is crying continuously or she is crying continuously, her face will be turned from normal to abnormal. The skin will be, the color, we can see the difference of the skin color. So that will help to identify whether the person is normal or abnormal. Even the over happiness, if they are laughing continuously, that the fair complex we can feel very clearly. Their face will turn to red if at all they are laughing continuously. Or if they are crying continuously, there are again a possibility of getting the skin turning over there. So that those things will be observed, and we can observe the same thing through camera. Maybe we can use it as an additional content, but this that is electrodermal activity, this is another sensor-based emotional detection, and here indicator of sympathetic arousal. So now the skin conductance, when the skin turned into, means mostly they will consider that as a downward. They are getting down into their level, and excellent for stress. So this kind of devices or the sensors will help us to find the stress, excitement, cognitive load. That is, they won't talk much, but they won't share anything. They will keep everything inside the mind, and we cannot able to identify how they feel. So these kind of that is sensors will try to find the skin that is complex, and from that it will try to give the level, and from that we can identify whether mentally they are disturbed or not, and that signal will help us to identify. Okay, all these are all medical based content, and even I have never come across the data of these things, but these are all that is the information given by the researchers. Okay, electrocardiogram, that is ECG, these are all known for everyone, and this will help us to capture the that is autonomic regulation. So now, when our heart is not normal, if we are having high fear by thinking something which is not at all required, and unwanted things, if at all we are imagining, and some situation we can go for imagination. If at all we are watching some horror movie, definitely we will have some that is a high beat heart that time. So that time this ECG level will be high. So now the situation, the surroundings, it is not going to be permanent, but the situation at that time, it will disturb our heart. And this will help us to identify the emotion of the current state of that person. The next one is EEG, and the previous one, how it helped to identify the heart level. In the same way, EEG will help us to find the brain condition. So now this is an exclusive device, will help to observe the signal of the brain, and from that we can observe whether the person is normal or he is thinking abnormal. And even some kind of people, when they are going for suicide and all, that time, that instant, that their level of EEG will be high, because their thinking will be very, very high. So these kind of stress will be evaluated or identified through EEG. The same way, we can go for functional near infrared spectroscopy, and this measures the blood flow. So now in the blood flow also we can observe that blood flow will make different changes on different places. Even in the face we are getting red or different color, and if anyone is pinching, that place will get red. If you are having some burning, then that place get red. So now so many reasons our skin will get red, and here it is reflected in the skin in the top of the body. And in the same way, if there is any changes occur in the blood flow, and that will be reflected, and that will be reflected in the internal body, not in the external body, that is going to reflect your cognitive or emotional. So again, it is going to say about how we are thinking. If we are thinking in a positive way, then it will show in a positive way. If we are seeing a happy movie, then definitely we all will have a happy that is a mindset. If we are watching in a horror movie or some that is the murder kind of movie, definitely it will disturb our that time of mindset up. So this is for example only I'm saying. You can apply in the place when people are suffering with chronic disease and all. We cannot estimate their mindset up, because that much pain they will have, and they won't convey to anyone. So these kind of the sensors will help us to find in what way they are. Are they comfortable? Are they feeling very pain? Or they are not ready to share their thought, but they are still under stress. These things will be observed. So in that place, it is playing a vital role. And electromyography, and it is muscle activation. So in that, it is mainly on the face, and here it is in the eye. Some kind of tissues will be observed, and that will help us to identify the emotion of a person. And here this is again this is a place near the mouth, and while smiling or when we are angry, and based on that, this will this particular point will be identified, and that will help us to find the emotion type, what type of emotion the particular person is. The next model, that is here the physiological signal. which are all the ways means blood pressure we can take, and EEG, ECG, all these things, various kind of emotions, that is various kind of physiological factors we can take from by touching the physical body, and the sensors will observe our condition, and the observed data will be passed into the system. The system, it will do the analysis. So maybe any kind of analysis or any model what actually we have opted based on that, and it is mainly based on the frequency. So frequency means if I am taking the same kind of test before watching the horror movie, my heartbeat will be one kind. And while watching the horror movie, my heartbeat will be in a different way. Even after watching that horror movie, after 2 hours, but I won't come back to the normal, but I won't be in the situation while watching the horror movie, how I was suffered. Definitely, I won't be in that state. So now these time is much important. So these things will help us to make a prediction. So here he is normal. Now, when he is going for watching these kind of movie, then the prediction we need to, okay, after this, and how long he will be suffering. Then after that, in what are all the situation, he can come out, or if the situation not occurs, then how long he is going to suffer. All these will be actually predicted. Then the correct recommended action can be given, suggested for that particular person to come out from that situation. So time frequency, it is much important when we are going to talk about the emotional reduction. The next one, textual. So when we are talking about the text, even people, they have done a wide research by seeing the text structure. If it is having a straight one, the letters are writing in a straight way, then it is saying they are actually comfortable, they are normal, they can tackle anything like that. So now even that each font, it is telling about some kind of emotion. So if we are having serif, then it is telling about the traditional. So they are like normal, trustworthy, formal, and this is not a just like that words. By after doing intensive research on that each and every font type, people, they have given this final conclusion. And when we are going with the bold weight, that is whatever the words we have taken, if it is very bold enough means, then urgency, importance, aggressive. So now these are all the basic features they will have. And whatever the word they are choosing, if it is going to be light and thin weight, the letters, whatever they are choosing, if it is going to be light and thin weight, they are delicate, elegant, and fragile. So now these are all the basic things. It will help to identify the
Audible? Ma'am?
Ma'am, it is not audible.
really very sorry. Actually, I got disconnected. Am I audible?
Yes, ma'am. It's okay. You can
Sorry.
continue.
Sorry.
Yes, ma'am, you can continue.
Yes, ma'am. Yes, ma'am. Let me share.
Okay, ma'am.
Yes, sir. This is the thing actually we have seen. So now all caps, if at all we are using, always we are preferring only caps means, then we are shouting authority alone. So now these are all the basic things by research people they have identified. And from that, so even the text will help us to identify the emotion of a person. This is another kind of modality. Through that we can get our emotion, people emotion. Apart from, so now these are all the usual way of getting emotions, and now the emerging, because we have seen the drawbacks when we are using the individual modality alone for taking for the process, and that emotions are not sufficient. So later people they started to go for making the hybrid modality, multi-modal fusion. So they can go for combining two or more modalities, face plus voice plus that is physiological information. And here we are going to see the fusion in future, that is after these slides. So by using early, late or model, that is fusion, these kind of fusion they can apply. And the fusion, it is nothing but when we are collecting data from various channels, how we are going to club up. That is fusion. Multiple way, that is ways are there, and it is referred with the name early, late, and slow. So that we will see after seeing this one. Neurophysiological plus behavior. So neurophysiological means like that is a mind-based activity through IO devices we can observe. And in the meantime, we can observe their behavior, how they are acting, how their facial reaction, what voice actually, in what that is volume they are giving the sound and all, in what ways they are talking. So these things we can observe and we can use for the multi-modality. And digital phenotype, it is a smartphone passive sensing. So now from the phone itself, we can go for, and app usage. So which are all the applications we are using in the mobile. Even that will, it is another important research area in that, the mobile usage. Based on that, we can justify the quality of a person. So which are all the app people are using. Screen time, how long they are actually in, that is watching that mobile or whatever the particular content or that maybe for studies they can use, or they can use for entertainment. So for what purpose they are using, that category we can go with. And we can go for predicting whether, so based on the continuous watching, we can predict whether that person is normal or abnormal. Even so many other qualities we can justify. And wearable, that is IoT, we are all known about it now. Ambient sensing and smartwatches, smart home sensors, so many sensors around us in the home, and without even our knowledge, we are actually going along with the sensors. And all these are actually can be considered as a kind of channel for observing our emotional content. And this is, so various input sources we have seen. And in general, if at all we are going for a computational task, we will talk about three things: input, process, output. So we have seen the multiple source through where we can collect our, that is emotional content, that we have seen. Now we are going to see how the collected content can be processed. So now we are going for seeing about the architecture, how we can do the process. And now input sources we are collecting from three. Here we have taken 3 different channels, but you can go with n number of channels based on your actually convenience. And each one, it is going to do its own model. So uni-model. So which one, if at all it is going to be facial recognition, then the facial recognition process will be done here. If it is going to be a vocal information, then audio process will be done here. If it is going to be a IoT based some kind of heartbeat process, then that kind of information will be processed. And now we are going to send all the 3 in the processed information, and they are getting fused. So they are combined in the fusion module. Fusion is an important module when we are using multi-modality. So now in the place, all the different sources will be kept together, and these data, you can imagine phase is going to tell about the phase, that is eyes, distance, everything, and finally it is going to help us to find the emotion of a person. And next one, suppose input, second input is going to be vocal information, then the signal, whatever the audio signal we have received, and we are going to make a segregation among the features, and we are trying to find what emotion we are. So the same thing, but in a different features we are having now. So now when we are clubbing up the features, the number of or the volume of attributes will be huge. So now next, that is the challenge here. When the volume of attributes is going to be high, then the complexity of process is a challenge. That is, in what way we are going to make the prediction with a high accuracy, because each one may give a different emotion, and finally how it is going to conclude. That is another challenge here. So now fusion, after fusing or after combining all the features collected from various modalities, we are going to pass it to the classification. That is the deep learning model or any kind of classification machine learning model. So this classification, it is going to apply on the fused content, and that will finally help us to make a prediction. So now this prediction will help us how the person is going to be. And this is the architecture diagram, the working process, the working sequence. Now we have to know the fusion. Fusion means we know it is going to combine the features from various sources. How that is going to be combined, that is the thing we are going to see in the next level. So now it is multi-model fusion. So we are going to collect the input sources from various channel or various modalities, and here we can see extract feature from each modality, and we are taking the that is input feature from various sources. You can see, and all these are all the various sources, and you can see all these are all kept as a single one. That means you just imagine one table with n number of column. That n is going to be feature of this first source, feature of second source, feature of third source, all these put together. N, if at all we are getting, then all the n features will be kept together before going for classification. So when it is going for classification, we are having n features which are merged from various sources. And that kind of process, we are calling that as an early fusion. That means here it is only collecting the features, and we have not applied any classification individually. So we have collected the features, we have combined the features, then the combined features are used for doing the classification. So late only we are doing the, that is after collecting all that only, we are going for making that. And early fusion, classification is done at the end, but fusion is done at the beginning. So after collection, immediately we are doing the fusion. And because of that, we are calling this one as a early fusion. You can see face features we have collected from one channel, voice features we collected from another channel, ECG features we collected from the third channel, and all the collected features are combined together. Then the combined content will be applied into the classifier, and that classifier will help us to find the emotion of a person. So now this kind of fusion, we are calling it as an early fusion. That is, before making decision, all the content are merged up. The next one, late fusion. And here you can see train separate models per modality. That means I have collected my first channel data. Then based on that, I'm doing the classification. The classified content only passed into the next level. And here also I have collected my that is channel data, and I'm passing that into the classification. The classifier model will try to find which emotion it is. That emotion, the final outcome of that model, will be passed as input for the next level. So now here the late fusion means all individual that is modalities, it has actually its own feature. Then individually they are going to make a classification. The classified content will be given finally for making the end conclusion. So now individually we have a face, voice and text. And for that face we are applying first model. For voice we are applying the next model. For text we are applying the third model. So 3 different models we may apply, or there is nothing condition. That is, we need to go for, definitely we have to apply 3 different models. There is no restrictions. You can go with the same model, but you have to make, we cannot stick on with one model. We have to go for a trial and error, and we need to apply various models, and we can change and we can keep the similar model like that, and we have to find. So the first model, it is giving 80% of accuracy, what actually that information it extracted. The second one, it is giving 70%. Then the third one, it is giving 60%. And when we are going to combine these 3 together as a few state, we can go for taking the average. So in a machine language, we have seen one kind of actually ensemble model, voting ensemble model. So in the same way, we can go for finding the average. That is one thing. Or otherwise we can go for voting. So out of these 3, which is actually highest, 80 and 70, and these 2, if they are representing the same emotion, then we can go with that. These 2 are saying about the same emotion, so I'm sticking with that. That is called as the weighting, that is a voting ensemble model. Average means you can take all these 3, then you can go for finding some calculation. Then based on the calculation, if it is between this range, then what emotion? Like that you can do, and finally you can go for making that final emotion. So now coming to this part, we are not having any model. So models are applied immediately after collecting the input from various sources. Different model or same model, based on our convenience, we can apply, and we are going to find the final end result, either by finding the average or by applying the that is a voting ensemble model. So this is the second one. This is called as the late fusion. Third one, it is slow fusion. And here you can see the modalities processed through separate branches. So sub-networks, they are having their own sub-networks, and interaction happens in intermediate layers via. So if at all I need some fact, that is features from here, I can take. And if I need some features from here, I can take. And for making the process, we can share the features, but all are not going to be mixed up. So based on the requirement, if at all required, it is little bit complicated. So if at all required, based on the requirement, the features can be mixed up and we can do the process. And here we can go for the cross-model attention, then tensor fusion, which are all the ways we are going to make a fusion. Then gated and transformer-based fusion. This is the the best way of making, and it is complicated one. And memory networks, all LSTM, that is these are all like deep learning process. And here face, it is having one model, and voice, it is having another model. And here we are having cross attention. If at all, which are all the features I need, I can collect and I can go with that. Then I can go the fusion layer, which are all the things I need. So no need to pick up all the that is collected data. I can select from these layer, I want to this, or from the modality of this one, I want these are all the features. And from that one, I want this one. Like that, I can go for selecting that fusion. Then finally, we can go for making the classification. And this is a little challenge when compared to the first 2. Okay. So the easiest one is the first one, but it is very time consuming. Why? Because it will expand the number of attributes. And the second one, it will be okay, but it will take much time. Why? Because we are doing separate process of individual models for individual channels. The third one, it is like a hybrid. So it is, we are selecting the features which are all needed, and wherever needed, we can go for fusion. If it is not required, we can keep separately. And we can do the process. And this is about the third slow type of fusion. So these are all the 3 types of fusions that can be applied when we are trying to go with the multi-model modalities. Then next one, evaluation. So whenever we are constructing a model, the model evaluation is much important. And here the accuracy, as usual, whenever we are talking about the machine learning model, we will simply go with accuracy, precision, recall, F1 score, anything. It is a kind of a prediction. So how far your prediction looks like. And if it is going to be a continuous data, where we can take continuous data means, if I am taking the student who is watching the class, that is if he is listening the class in online, so I'm capturing through the the student's information, that is like a continuous data. And that I can, that is if I'm not interested on the video, I can take his, voice, how interactive he is. Based on that, I can go with that. So regression metrics here, if at all it is going to be a continuous data, then we have to focus on the error, that is calculation for continuous and dimensional effect, and concordance correlation. So how far it is, that is what we are expecting and what we are getting. So that correlated contents we can, and temporal metrics. And this is like telling about the time, that is based on the time. We cannot say all that emotion going to be same always. It is not going to be a fixed one. So when it is going to be, in what way it is going to change. So the temporal metrics are also important. We can say, so in this situation or in this duration, that particular person reacted like this. And in this, when he is suffering with a very severe cold, fever and all means, then the way of talking of that person is looking, volume is less. Even if he is very angry, and that volume, it won't come out, and that will be looking very less noise or less volume. And that if at all you are going to take with only the vocal information, then due to that less volume, and it will say, no, he is normal. But actually he is angry. But due to his physical problem, he couldn't able to raise his volume, and those things cannot be. So now that temporal, so that situation. So due to his illness, he couldn't. Otherwise, he can be in a normal. So that temporal, this is one example, but you can apply in a medical also. So when we are suffering in a problem and while taking treatment, if we are getting cured, then we can say, so when we started and when we started to get cured, and how far our actually the recovery, and that also we can make an analysis. So detection, delay, stability, smoothness, everything we can make it as a metrics to evaluate how far our model performs. And benchmark data, these are all the standard data set people they will use for the emotion detection analysis. And coming to the application. So now we have constructed the model, and we have evaluated the performance of the model. So which are all the ways we can evaluate. And now we are going to see which are all the places we can apply. So the first one, it is medical domain. Already I said we can go with, this is one simple diagram I gave. It is with respect to the wearable devices. But no need to stick on with only this. You can extend your imagination, because this is actually a upcoming research domain. You can, that is, extend your imagination in a medical domain, in which place we can apply the emotion detection to find the feel of a patient, and based on that, in how far we can give the treatment. And when we are going for the online treatment, now I think most of the people, they are going with online treatment. In most of the places, it is common after COVID. So if at all they are not having time, they can go with online, that is video interaction. So over the interaction, the doctor can observe how the patient is interacting with him, and he can observe, or he can even capture with the permission of the patient. Okay, without permission he cannot. Nobody is having the rights of capturing anybody's personal content. So with the consent of the patient, and he can observe or he can capture the face reaction and the audio convey how the patient is responding. Based on that, he can. And we are not bothering about the content what he is delivering, the action, that is the signal we are going to. So whether he is under more severe, that is severe pain or pathetic condition, or normal condition, like that. So the facial reaction and the audio, those two we can take. And the sensors and all, when we are going with that is video treatment, that is not sufficient. So with these two, we can go with a multi-modal modality, and we can combine the models. We can either go with the late fusion or early fusion, or whichever it is possible. We can try to find how the patient is feeling now, today. Suppose if he is coming regularly, then we can combine with the previous data. And from that previous data, if the model is trained with the previous data set of the same patient, then if the current data signal or the modality signals are given as input, immediately your system can able to say the patient is normal, he recovered, up to 20% recovered. Even up to that level, we can do analysis and we can make a recommendation. Okay, he only that suffering with 20%. So light that is treatment or light medication is sufficient. That kind of recommendations we can do. In any extent, in medical domain, I think in future we can expect. So this is going to be the that is emotion. With the emotion, we are trying to find, or without disturbing them, we are observing and we are making an analysis, and that analysis will help the doctors to make a better decision without disturbing the patients. That is one application. The next one, it is in education, and here even it is helping to improve ourselves. So there is a virtual tutor. I think you are all known. We are all living in the AI era. So many AI tutors are available. And then before going for the interview, if the student, he wants to improve himself, then he can open that. I think I want to show that. And this is the example to that is improve the that is a person's quality. This will that is if you are sitting in front of that actually Mac, and it will talk to you. It is like a bidirectional communication. It will talk to you and it will say which are all the modulation you need to make a change. So you may say hi, then he can correct you. You should make your hi in a enthusiastic way. You should not convey that in a dull way, and so many corrections. And this is one kind of that is improvement people can feel, that is especially students, they can make it used to improve themselves. And it is not going to that is, if at all the friends, if we are trying to make them or use them to improve our skill set, in some state there is a possibility of getting backfire from them. We are all human beings, so that is quite natural. And when we are depending these kind of conversational system, and that is going to observe you through the camera and audio signal, then it is going to make a correction whatever it is required to do, and it won't disturb you in future based on the action whatever you take. So that is the safest one. And here we cannot give an assurance always it will take us in a positive way. So we have to use our intelligence also when we are talking to the bidirectional system. This kismet, this is another important that talking that is robotic we can say. But the main drawback what later after that is constructing this, it is functionality wise pakka. It is doing its task in a pakka way. But where it is getting actually in a negative way means the appearance. So people, they are not interested to see the appearance. They are interested to see or interested to utilize their functionality. So the appearance is a matter here, and nobody, that is majority, not nobody. And majority of the people, they are actually not interested because of its appearance. Even it is a study they have done, and that is whatever the conversational system we are going to develop. And that should be a smooth communication, or the appearance also matters here. How far it is going to communicate, that is important, the functionality important, but the appearance of that conversational system is also playing a major role when people are getting interest to make a communication. to start the communication. Once they have started, then they will continue, no problem. But due to the appearance, they are not coming means it is not actually good. So that is the one research they have given. The appearance also actually matters when we are going for preparing our own conversational robotics or whatever it is. And the next one, it is going to be a that is decision making marketing. In the marketing, how it is helping. So consumer, they can go for making their that is inventory. They can go for making that whatever they need. They can go for, and emotional appeal. So they can see the item, and one item they can see immediately. It may attract, maybe due to the advertisement, or due to their friends, that is a positive feedback about the item. So many matters are there, but that is advertisement. I think you are all known. It is making a huge impact while that is going for purchasing. So okay, these are all the items most of the people they are using, or most of their own ideal stars they may use. So people, they may stick on with that and they'll go for. So that emotional appeal in ad. So they may stick on. So for this ad, my star, he came, or that my that is a family people or someone. So in some way we may get emotional bond with that particular ad, and that will get into the attitude towards that ad. So now that may take you in a positive way or negative way. Both are there. So now positive way will take you in a high sales in that particular item, and negative means it will that is decrease your sales. So both will be there. And finally the purchase. So now that is digital marketing with intelligence or emotional content or emotional bond. For example, if one person he is very expert in a car driving, and when a person is seeing a new car, then immediately he will say, okay, if I'm getting the key, I can make one trial, I can make a test ride, like that. If a person that is not interested on driving, or he is not known about the driving, when the key is given to him, he can keep the key and he can, that is the emotion. So he won't get any emotion towards the car because he is not having the previous experience. So the previous experience also matters, and that is actually the emotional appeal. And the person who got much impressed and he is interested to go for making a, so that is test drive means already he used some car and he is interested in driving actually, and now that car is also maybe one of his favorite type of model, and if at all he's so that is the thinking of himself. If I'm having a key, definitely I will go for a that is one mini, that is a drive I will go. And the other one, even if you are giving the key and he is not having, why? Because previous experience he is not having. That previous experience may come in different ways. Maybe the one kind through advertisement we can get. So this is in that is emotion, how it is making the marketing to make a business in a high way. And ethical issues, this is actually a big content when we are talking about the emotion. And privacy and consent, we have to that is the emotional data. Emotional data, it is taken from the face, voice, physiological signals are highly sensitive. Why? Because all these are all purely private. So individual persons expressions and their own that is content, and lack of clear informed consent on how data is collected, stored and used. So if at all we are not having the clarity about, we are collecting the information for making our research or for making an analysis, whatever it is, before collecting the data, we have to be very clear from whom we are going to collect. The client or the person who is getting involved, they have to give their concern. Yes, I don't have any objection. You can collect my face information, audio information, whatever that possible information, I'm ready to give. That concern is much important because all these are all very sensitive information. So privacy and concern, it is very, very, we have, even if at all we are collecting and we are not supposed to share it with anyone, because that concern will not be given by any individual. So any individual can give concern for the person who is collecting for their analysis or for their research purpose, and that person who is collecting should not misuse. And that way we have to make our agreement. So here the agreement, the legal agreement is much important when we are talking about the emotion information. And data security and ownership, and the risk of data breaches exploring personal emotion information. So now whatever the information we are going to collect, it is personal information. If one data, if it is leaked out about one that is patient information, mostly none of the hospital they will reveal. If it is coming out, then it is we can go for even claiming in the court. So now these kind of information should be kept as a very secret, and it is very high risky data, unclear ownership. So okay, one person he is collecting, okay, but that data it is used by some other person, that is the who are all getting involved to make the analysis. And that person, if he is trying to take the data, then again a problem. So now he has to be, the person who is collecting has to be very clear from whom he is collecting, okay, input is okay, and who are all going to handle, that should be very clear, and who are all handling, and he has to decide up to what level of data he can. So the name, it is not at all required. Age, it is not at all required. If at all required, we can provide the age without actually showing or exploring the name, address, and other very sensitive data, no need to explore. So that way we have to hide. So which are all the data we can share with others, which are all the data should not be always, should not be shared with others. And these kind of that is clarity should be required for the owner who is taking the responsibility for the data. The bias and fairness. The models may be biased because the models can be in both ways. It may do good or it may be due to the non-representative data set. Non-representative means it is like a cultural, gender, because if at all we are talking about the cultural, and it is like a crowd. Cultural means some function. So it is going to be a crowd, and the crowd, how it is going to be, nobody knows. So now in some places we may have more noises, but people will be happy over there. And in some places we may have different sound, but they are not comfortable. So different that is scenario will be there. And gender, it is much important because one person, that is male can have a female voice, and the one female may have a hard voice like a male. So now that alone, that is the voice alone will not help us to make a emotional prediction. Suppose that the male voice, if it is identified wrongly as a female, then that final emotion, it is getting into a wrong place. And the next one may lead to unequal accuracy across demographic. So now here, whatever the system I'm applying here, or whatever the faces or whatever the images I'm capturing here, I cannot expect the same comfort, the same facility in another zone, because they may have so many other set of rules. They won't allow the camera, they won't allow, no, the camera people, you have to stand after that is half kilometer or 1 kilometer. So many restrictions might be there. So now in one geographical region, how we are getting the input, we cannot expect the same way from other geographical region. So many restrictions are there. And even with that, if at all we are going to, and we have to be very careful what we are collecting and how we are going to save it. So now where that privacy or the ethical concern comes here means the private data. When we are getting into the group data, it may help in future. Even the Smart India Hackathon, we got a problem. From the group, we can identify the issues, what are all that. So this emotional content we can include for making the, that is identifying the group, what they are. And if any unique person acting in a different way like that, we can make a category. So that these kind of ethical issues we have to focus, especially private. When we are focusing on an individual person, then it is very high. If the coming with the group, it will be little limited, especially with the geographical limitations like that. Other than that, we won't have much limitations. The next one, misinterpretation and reliability. So now here the emotions are context dependent. So now in what way we are going to convey, that is the emotion, and same signals may not mean the same emotion across people. So now if one person, if he is saying it's okay, looking good, and sarcastically he is saying means we cannot say it is really good. So now the same, all the words, the way he conveyed everything looking normal, good, okay. But the way the sarcastic notation, it is saying it is not good. So now we cannot say always whatever we are saying, it is going to take us in a correct way. And over reliance, that is reliances on imperfect predictions can lead to wrong decisions. So now if we are doing that is wrong prediction, then it will lead us into the wrong thing. So that is whatever the data we have collected, it should be from the correct source, and that should be ensured before making the prediction. The next one, manipulation and autonomy. Predicting the emotions can be exploited for emotional manipulation. So whatever the predicted emotion we are trying to go for, it is actually for emotional manipulation. It is like a kind of emotional extension in advancing our political campaign. So now before getting into that situation, we are making one that is overview. Okay, if at all we are having like this, then we may have like this. So that is actually a manipulation. Before getting into the situation, we are making a prediction how it is going to be. So users may lose autonomy if systems try to influence their mood or decisions. So whatever the action or whatever the emotion predicted by the system, it should not actually affect the individual or any group emotions. So whatever it is, okay, it is giving like that, but there is no assurance we are going to be having the same emotion at the end. Okay, some changes will be there or may be there. And whatever the prediction we are doing, it should not affect the group or individual. And transparency and explainability and black box AI model make it hard to explain why. So almost deep learning, we can say it like a black box concept. So a certain emotion was predicted. So now it is finally giving some emotion, and how it is making the prediction, we need to make a mathematical calculation, but even that we cannot do for all the data. That is a big challenge. So now when we are giving the data, then inside that actually it is doing some process, finally it is going to give. So inside that, inside the neural network, what process it has done, it is still a question mark. So lack of accountability when predictions goes wrong. So now if the prediction goes wrong, what action will be taken? That and all we cannot claim. So it is a kind of a system we are trying to go for making a prediction. It may go for a successful way, or it may get into the different emotion. So there is no assurance we can give about our predicted emotion is going to be the 100% success always. The next one, physiological and social impact. Users might feel constantly monitored. So now, if at all we are going to observe our features or our face, that is the information are extracted, means they feel not comfortable. So that may lead to that stress, or they can change their behavior. They are not normal in their behavior. So this is the normal. So physiological changes will be there if a person is having, he is observed continuously. So when he is having that feel, then he started to react in a different way. So this is also another risk. For example, if we are taking, if a person started to watch continuous some kind of reels or something, even after 3-4 hours, he is continuously in the mobile without even talking to a single person. So that is again abnormality. It is really we have to look into that. So that will isolate the person from the society. It is a kind of that is evil power. It is taking the people away from the society. So these are all the things we have to observe, and we need to go for making the recommendation or remedy for that. and risk of emotional profiling and affecting jobs, insurance, credit decisions. So now if emotional profiling, so it is, if we have stamped a person, he's short-tempered, always he will shout for everything. So if at all we are that is branding a person, then that will affect their own career, that their own profile, everything. The next one, legal and regularity challenges. Few laws explicitly cover emotional data handling. So now we don't have a well-defined laws to control the emotional misusages. Still, then and there, that is even the IIT people, they are saying when we are going to get a emotional data extraction, we have to make a clear legal bond signature, and we have to get agreement from both, concern from both sides, and that should be legally recorded. And these are all the few things actually it is few laws are there, and need for compliance with which are all that is ethical guidelines, biometric data regulations. So now which are all the ways we are going to make actually, if any issues raised or if any problem comes there, then in whom to be approached, in what way we can get a solution for that. We are not having clarity on all about that. So these laws should be actually refined or reframed, or we have to structured freshly wherever it is required. So these are all the ethical issues with respect to the affective computing. Let me go for a demo. Ma'am, shall I go for a demo or shall?
Yes, sure, ma'am. No problem.
Yes, ma'am. Thank you. So now I'm not going to make any execution. Why? Because if I'm executing it, it will take time. So now this is an that is I think you are all familiar about Colab. Just I used Colab, and this is the file I have that is installed FER. And next, by using that, I'm going for taking a photo from the net. I think you are all familiar about Lena.jpg. Lady, that is a single lady. She will be like a mild smile. She will be there. If we are going for image processing or OpenCV, and this image is mandatory for doing all that basic image processing task. So this image I have taken, and I try to find the emotion. What will be the emotion that image it is trying to give? It is not a prediction. It is a deduction. Okay, prediction means continuously we need to observe. Then the continuously observed data should be used to train the model. From that, we can go for making the prediction. So that previous step is a deduction. That alone, I'm going to make it like a demo means I'm showing the outcome. So now here it is giving, these are all the ways. So now we can see the percentage, the emotion. It is the emotions. First one, angry, it is 13%. Disgust, it is 0.0, and these are all given here. And finally, it is telling, because the neutral, it is taking 56%. So this image, this lady, how she is looking means emotional wise, she is neutral. So she is not anger, she is not happy, and she is looking neutral, normal. And no emotions can be, that is normal. She's not excited, not fear. Okay. And next, actually, I have kept some files in the drive, and from the drive. So now these are all the files I have kept in the drive, and these files I'm trying to make that as the use for it. And here, this is, I think these two lines, to fetch the data from the Google Drive. And I have executed already, and I don't want to disturb now. Just let me show. So now these are all the libraries, what I need to use for my process. I'll share this one with the madam, and you can use it if at all required. So now, this is the file I have taken, and pre-file I made a try, and here I have taken this one, and I'm going to make the emotion how it is. This is the data set I have taken from the Google. second. Just like an individual person. Which image actually I have taken means, let me show. This is the image, and this will give us a fear. So the eye opening, the mouth opening, and the nose distance, all this will help to make it like a fear. And this is the image I tried to put it over there, but I think it is not. I got the that is output, but now it is not shown. Next one. Before giving to you, I will do all the corrections, and I'll make everything pakka, then I'll share you. Then the next one, it is going to be the group. One second. So now this is a group identification. You can see here. So this is another image. We have taken a group that is emotion, happy, and surprise. And this one, it is considered as like a fear. Okay. And here, if at all you are going with the voting concept, means one it is fear, one it is surprise, and the two are actually identified as happy. How the data are taken from top left corner down towards this one. So that way the phases are considered for doing the analysis of emotion detection. So now the first phase, it is considered as a fear, and this one is happy. This one, it is even though it is looking that is happy, but due to that smile is missing, no? So because of that, it is considered as a surprise and happy. So now two actually emotions are happy. They may be considered as a happy emotion finally. And the next one. So here it is taking only the first image out of this. So out of 4, the first one alone identified, it is a fear one. But it is not fear. That is the drawback with respect to single modality. We have taken the image alone, and even though he is looking not fear, but based on the points, whichever the points it is taking, based on that, it is making a prediction of fear, or it is making the detection of fear. So that is not correct. So if you want to improve, then you can go for taking the voice also. So that may improve our information. So these are all the supporting documents. Here I have tried to combine image and audio. So one image I have taken. While doing this only, before all that actually got disturbed, and here I have included image and the audio. When combining these two, we got finally, if you are running this, you will get a neutral. So because I gave the group image with the 4 emotions, no, fear, happy, and one it is surprise with some noise. That is some volume I have given. The volume it is given as like a that is people in fair ambience. So the laughter. So that is the audio. That is audio volume I have given from the Google Drive. People in fair ambience. So this is the audio. I hope you can hear. So this is the audio combined over there, and that image with this audio, finally it gave that is neutral. It is not happy like that. It is giving the final emotion as a neutral. So that was the final result I got. And the next one, it is like a sentiment analysis. You are all known about the text analysis. So it is a kind of prediction. So I have taken some tests and we try to go for making the confusion matrix. So how far we are getting that. So now that is one we have taken from 0 and 1. and it has identified 50% the precision. It is going to be that is 50% with respect to one class, and one means positive, negative. That way we can say. And based on that, we got the output confusion matrix like this. And this can be extended for big volume of data. For sample, I have taken very few set of data, and out of that, one each we have taken. And when we are trying for that is model or research purpose, we can take some enormous volume of data, text data. For that, we can apply. Before that, we have to go for all the NLP pre-processing, and then we can go for taking the emotion. And this alone is not sufficient, means we can combine with the additional other modality based emotions. That will give a better solution or better emotion prediction. So I will do the that is corrections wherever required before sharing the content to madam. Okay. So I think I can wind up here.
Yes, ma'am.
Yes. Any doubts?
Yes, participants, please note feedback form is shared in your chat box. Please fill it. Thank you, ma'am, for your insightful session. We will now take questions from the participants. Kindly unmute yourself or type in the chat box. Any questions? Any
No,
questions?
miss. No, miss.
Okay. Now I invite Mr. Jaswin Joseph, Assistant Professor, for the vote of thanks.
Good evening, everyone. I am honored to deliver the vote of thanks for today's insightful session. On behalf of Nirmala College, Muatupura, Department of Computer Science, and all the participants, I extend our heartfelt gratitude to Dr. Tamil Selvi ma'am for her insightful session on prediction using affective computing techniques, application, and ethical implications. Ma'am, your expertise and passion for this topic was truly shown throughout the session. We are grateful for the time and the effort you invested in preparing this session so that we got a clear full idea about the methods and techniques used for predicting emotions. Once again, thank you, ma'am, for your truly inspiring session. Thank you all.
Thank you, ma'am. Thanks for inviting me for sharing my thoughts.
Thank you once again, ma'am.
Thank you, ma'am.
Thank you so much.
Shall
Thank you,
I,
Jaswin, sir.
shall I sign off, ma'am?
Yes, ma'am. Sure.
Thank you. Thank you.
Thank you, ma'am. It was a very informative session.
Thank you, sir. Thank you so much. Thank you. Thank you all. Thank you.
So let's move on to the second session, which is handled by Dr. A.C. Shandashila, ma'am. I invite Tini Tamban to welcome her.
Dr. A.C. Shandashila. She's an Associate Professor, Department of Computer Science and Engineering at Satyabama Institute of Science and Technology, Chennai. She was awarded a PhD in Computer Science and Engineering from Satyabama University. She has over 20 years of teaching, research, and administration experiences. She has published many research papers in reputed journals and conferences. Her areas of interest are data mining, artificial intelligence, AR, VR, natural language processing, and Internet of Things. She is a life member in ACM and ISG. She has received Global Excellence Award for the achievements in computer science educational leadership in 4th Global Multi-Track Virtual Conference and a Global Excellence Award Star 2023 organized by Special Minds India and Unified University Brazil, South America on 2023. On behalf of Nirmala College, Muatupura, we welcome you, ma'am.
Thank you. Thank you. Shall I start, ma'am?
Yes, ma'am. You can start
Okay.
the session.
Yes, thank you. Good evening, all. I would like to thank Almighty who provided this opportunity to me to be present in front of you. And then I would like to thank top level management of the Nirmala College and then the organizing committee of this event, um, the heads, deans, and then the staff coordinators, everyone. And then I would like to thank Elizabeth. She is my friend. Thank you for providing this opportunity. Okay, before starting this session, I want to give quick warm up. Okay, I would like to share my screen. Okay, I hope my entire screen has been shared.
Yes, ma'am.
Yeah. Will you please scan this QR code quickly? I hope you people are scanned. Is that opening? Did you open that QR code? Can I get some response?
Yes, ma'am.
Okay, fine. May I know what happened?
Cannot send money to the recipient.
No. Can you able to scan this code? QR code?
Yes, ma'am. I saw scanned it. It's a game.
Yeah. And then you got that level 1? You got that 3 3 cross 3 into 2 6 flip cards.
Yes, ma'am. I got it, but I don't know how to play that.
You have to click that. You have to click. You have to match. Once it has show the cards and then it has been turned back. Now by remembering that which card is that, you have to map it. Did you map it?
I mapped 2 bones.
Okay. Thank you. Now I am stop sharing here. Okay. I hope you people are what enjoyed with that small game. That is, now my question is, where did you play that game? On your device?
Ma'am, I completed the level.
Okay, fine. Thank you. My question is, where did you play it? Is that game is in your mobile? The answer is no. Yes. Thank you, Sijo. Sijo Jacob is with me. Okay. You saw the flip chord on the space. Okay. So that is my topic, spatial computing and its application. Okay. So before moving to that topic, I want to quickly show something. Okay, already the time is up. That's why I'm just interpreting now. Okay, I would like to share. Okay, I'm Dr. Shanta Sheila, Associate Professor, Department of Computer Science and Engineering, Satyabama Institute of Science and Technology, Chennai. This is my topic, Introduction to Spatial Computing and its Application. Okay, so in this session, we are going to discuss about that welcome and objectives, Introduction to Spatial Computing, technologies, component, application, and characteristics. Then the software comparison between the Unity versus the Blender, component of Unity, physics and rendering, VR prototyping, and then the wrap up and question and answer. Okay, without boring, we will directly get into the topic that what is spatial computing. It is the integration of digital information with the physical world, allowing the devices to sense. Now you can see on the right hand side the device. Here the device is the mobile. Okay, it is sensing. So the sensor is the camera as well as the GPS location, which sends the physical data, okay, and interact with the real world spaces. Okay, now the building, it may be a restaurant or the hospital, anything, whatever it's available in that location, it has been detected. Okay, the human can interact with the things. Okay, interact with those things via the device. Okay, and objects, these are all called as objects. Okay, any building, any infrastructure, anything can called as objects intelligently. So it creates immersive. The immersive means it creates the experience, the feel. We are observing something. Okay, immersive interactive environments where the digital and physical realities merge. Okay, so here something is the real one, the remainings are the digital as well as that imaginary. It's not a real one. Okay, so the technology involved in the spatial computing is augmented reality, virtual reality, mixed reality, sensors, IoT devices, and then we are having the computer vision, AI, and 3D mapping. What is meant by augmented reality? When we are trying to bring the virtual thing into the real world, then it can called as a augmented. You people are well known about the Snapchat. In the Snapchat, we are having the real face with the artificial nose and ears. Okay, so that is the human is a real, and then the nose and ears are the augmented. Okay, so augmented means we are trying to bring the virtual into the real world. So look at here, the room has been scanned, and then the sofa is a virtual one. They are trying to place the sofa on the hall, whether it is suitable or not. And then virtual, you can see here, when the people get into the virtual reality can called as a virtual world, can called as a virtual reality. So we needed this device, the what they are wearing, that device can called as a head mounted display, HMD. Okay, head mounted display. So they are completely in the virtual world. They are not aware of the what is happening around us. That is, they are not uh, aware of the physical world. They are in the virtual world. Okay, mixed reality is the combination of augmented and virtual, can called as a mixed reality. Sensors, as of now I told, camera is the sensor, GPS is the sensor. Okay, there are so many sensors. Gyroscope is the sensor. Okay, in your mobile you are doing the flip, no, horizontal position, vertical position. Okay, that can called as a sensor. Okay, based on that it is sensing and then turning the entire thing into the either horizontally or vertically. And then IoT devices. Computer vision means identifying the objects on the image and video can called as a computer vision. Nowadays, everywhere this technology has been used. So look at this picture. So here this image has been examined and then it's specifying that there is a pot and then there is a car. This is the person and then here you can see the car and then this is the traffic light, so and so. Okay, so and then AI, you know very well, artificial intelligence, and then 3D mapping. It's not a regular 2D mapping. We can able to view some models on the map that can called as a 3D mapping. So the combination of all these can called as a spatial computing to blend the digital and physical environment. Okay, so the technologies evolved in the spatial computing is augmented reality, mobile AR, mixed MR, and then the virtual R. So what are all the key components are there? What are all the purposes are there? So the key components are AR, VR, MR, and then the for this we need a headset. That's why I said HMD, head-mounted display. It can called as a MetaQuest. Wrist Oculus wrist. There are various devices are there. Oculus wrist devices, AR enabled phones. Now another device, just everyone in your hand, we are having a AR device, that is your phone. Okay, sensors, camera, GPS, gyroscope, and then the lidar is a light, distance, and range. Okay, this which helps to what exactly find a distance between that one object to the another object. That's why they mentioned that lidar to map space. Okay, and then the 3D modeling tools, we are having the Blender, Maya, and 3DX for creating the virtual object, and then AI and the computer vision, which helps to recognize and track objects, gestures, and faces. Okay, so here in this example, we saw the to identify the object. Okay, person is an object, car is an object, anything is an object. IoT devices, if required, we can connect the smart objects to interact within the environment. Okay, so we are having the AR, VR, SDKs, software development toolkit is the, and then the platform, Unity AR Foundation, Unreal AR Kit, and then the Euphoria. Euphoria is the software development toolkit for developing the AR application. Okay, so as we discussed, what is VR? When you are getting to the fantasy world, that is the VR. The AR is when you are bringing the fantasy world into the real world, then it can called as a AR. Okay, so for this we need some input, processing, and the output. So the input are using the mouse, we can give the input, and then what the hand control devices, we can give the input. The lady, what she is wearing is can called as a data glove. Data glove, via the data glove we can give the input, we can give the gesture, and then head mounted display, HMD, that device via the head rotation, we can give the input to the input for the processing. Okay, and then it has been processed and then it will produce the output to the same HMD. Or if you are setting any screen, you can see the output on the screen itself. Okay, so there are full bodysuit avatar film, you know very well that and all. It has been developed in the studio itself. Okay, so you know very well that what in the entertainment means in the film industry also this type of concept has been used. Okay, so the AR navigation overlay on the streets. Okay, as of now in our country we are having only taking left, right, so and so only, but in advanced in America, USA, that and all, we can this AR concept is integrated on the map. Excuse me, sorry. And then virtual try-on apps for jewelry, clothes, makeup, and then the smart factories where the machines and robots navigate and interact in a mapped space. And then immersive retail experiences, healthcare simulations. These and all we can experience the training for the surgery. These and all examples of the spatial computing. Okay, why now we are look up that AR VR? Because the devices is smaller, lighter, and cheaper, and then it is more powerful, and then the big companies have started investing on it, like Facebook, Google, Apple, Samsung. They have started investing in dollar as well as the euro. Then the usage of these solutions are giving the growing in the collaboration, training, and then for other benefits. So what are the use cases of the AR VR? Here, game and entertainment. Just before starting the session, what you feel or immersive is what? VR games, AR games. That is an AR game. Okay, face filters. Okay, I will show this. Product marketing and sales, education training, travel and tourism, architectural, product design, scientific research, supporting tools for the work task. These are all the use cases of the AR. Now we can see it one by one. This is the game and entertainment. So this left hand side, you know very well, it is a Snapchat. The right hand side, who didn't scan or who didn't play, this is only your friends are played. Okay, so this is a matchup game. Okay, it will show outside of the screen. You can see here my laptop screen is there, and then the flip card is displaying outside of the screen. Okay, so if I match, that is there are two persons are there, two coffee cup are there, and then the remaining are both are what? Same. The remaining two images are the same. If I map, then I will clear the level. Okay, so this will give some instead of playing the boring games, it will give some experience that I am in the virtual world. Okay, something. And then education and training in the schools. Okay, if it is a textbook reading, means it may be boring. Instead of they are seeing their model, okay, by their own eyes. Okay, so they are enjoying the learning. Okay, so in the education and training it has been used. And then product and marketing, sales. Okay, we can check it before purchasing it. We can check it by giving the measurement of the height, weight, and then the any color, that and all. By giving the details, you can purchase your dress. Okay, and then this is the travel tourism. Okay, if you are going to the new place, if the device is there, it will detect that what is the place. It will give some additional information that where the ATM is, especially when we are moving to the new places, we doesn't know language, so and so. Those times, this applications are the AR based applications has been used. And then architectural engineering. Okay, instead of 2D map or drawings, okay, we can get the better experience in the 3D models. Okay, and then the product designs, cars and smaller products. This concept has been used. Okay, so you can see here scientific research, medicine, healthcare, and rehabilitation. Okay, the left hand side may be after some age, if the hand is not functioning properly, means the patient won't be a cooperative one. Okay, if we insist them to do something, they will hesitate to follow up the instruction. Instead, okay, now look at the right hand side picture. Football court is there, ball is there, and then the uncle may infected by the leg fracture or something. After some time he recovered, and then now he need a practice that to move to give the leg movement. Okay, so now with the help of the technology, AR technology, he is going to getting the practice. Okay, this is the way we can use it. Okay, so what is the characteristics of the AR? It is an interactive one, and then it is an immersive one. It is a multi-sensory. Multi-sensory means not only the viewing, and also we can hear sound, audio system, and then some for some haptic devices and all, we can touch and feel. Okay, so that only can called as a haptic device. And then here synthetic means it is not a real. All these are all the artificial one. So these are all the characteristics of the VR. It should be interactive, it should be immersive, it should be a multisensory, and it also a artificial. Okay, so the technologies along with the VR is head mount, as I said earlier, head mounted display, motion tracking, input device, output device, as well as the sound system. So Oculus Rift, which helps to what you by rotating your head, you can give the input, and then you can track the you can track the scene. Okay, rendering means converting the 3D scenes into the bringing that into the 3D view. That can called as a rendered, that we can do. Okay, so HMT track the movement of your head. Left hand side, if you look, means then you can able to see the left hand side images seen. Right hand side, if you look at, means then the right hand side images you can get into the eyes. Okay, the scene based on the orientation as well as the location. Orientation means okay, I will show you just. Okay, you can see here. Okay, this is only I want to say about that orientation and location. Orientation means in which axis I want to see. Okay, from the x-axis view or y-axis view or z-axis view, and then the location means left hand side, right hand side. Okay, so here based on that we can able to, that is the Taj Mahal 360-degree view. Okay, so we can do that. This process is similar to how we look around in the real life. It gives some immersive experience. Okay, and then motion tracking. This is only what I said now. This is used to track your head. Okay, there are two types are there. One is a rotational tracking, Another one is a positional tracking. So this rotational tracking has 3 movement: pitch, yaw, and roll. Nothing but x-axis, y-axis, and then the z-axis. And then position tracking means if you want to move forward, move backward. Now, in the Taj Mahal example, I show you that I just move forward and then I shown the move backward, and then I just look up, try to view from the up, down, left, right, so and so I did it. So this is the input device. Input device, I already told you are having the gamepad, mouse, keyboard, data cloud, body suits. These are all the input devices which takes the input from the user and then it will convert into for the processing. And then the output device, this is only, we can call it as a Oculus Go, Oculus Quest, Oculus Rift. This is called as a head mounted display. We have like a helmet, we have to wear it on the head, and then for each eye we are having the vision view. Okay, for left hand side, left view, like a telescope. In childhood days you may see the telescope, no, like that. For left eye, right eye, you are having the separate screens. Okay, Oculus Rift, and then mobile web. This is the iOS, Android, cardboard. Initially Google, very first time Google has introduced that Google Cardboard. Later they stopped the production. Okay, so our topic is our theme is that AI related. So how this AR VR used in the AI concept, that we are going to discuss. Okay, so computer vision, it means what? The object should be recognized. So here they mentioned that what? There is a ICA Place app. Okay, so what this app will do, I will show you. Okay, this is the ICA app. Okay, so this is your hall, and then these are all the furniture, and then which furniture you want to purchase, then you can check it with the color, the furniture, any model. Okay, this is only can called as a ICA, ICA app. Okay, ICA Place e-commerce app design bring the future of the 21st century. Okay, you can see here. So this is only they mentioned here. Okay, so computer vision, object recognition. So here we are recognizing the object sofa into our home. The object is the sofa, is the virtual. All the remaining are the what? Real. Okay, so the plus is we can't. Okay, after keeping the sofa, and then if you take the picture, then you can, until you reveal the truth, no one can say that what the sofa in your house or not, like that. We can't able to split that which one is real, which one is a artificial. If it is a Snapchat, the dog nose and then the ears means that time we can able to split it. But now this and all we can able to split. That only I want to say. So you can see here, Oculus headset track the hand movement, and then natural language processing, voice controlled AR interfaces, spoken commands in the AR glasses. Okay, we can give the what voice command. I will show you. Okay, look at this project. Okay, this is our Unity screen, and then one object has been added, that is the cube. It is a 3D object. Okay, as of now I just give the command. Later we will see that the entire Unity clearly. As of now I just want to show the voice command. Okay, glide. Did you notice that initially the object was in the middle? Now glide means what? In the X and Y direction it has been moved forward. Okay, now I am saying down, down, down. Okay, so what happening it is, so I want to show you the code. Okay, you can see here. Okay, so the language has been used, and then using Unity Windows dot speech. So the speech recognition has been what? Observed. Okay, so the keyword recognizer, I didn't say a sentence and all, only the keyword up, down, move, forward, so and so. Okay, you can see here move, down, up, glide, back, retreat, stop. This is only I am using. Okay, so for this I am giving the command. If it is up means how much it should go upwards. Okay, so you can see here, if you studied the computer graphics, there you can say the study the movement, that is translate. Translate means what? Moving the object from one position to another position. That only can called as a translate. Okay, forward means initially the object is in the 0 0 0. That is the, it's in the middle, in front of the camera. That is the 0 0 0. Forward means what? In the x direction, the object should move one step forward. Back means in the x direction, the object should move one step backward. If it is up means in the y direction, the object should move one step up. Down means in the y direction, the object should move one step down. Glide means now like bulty. Okay, so it is what? In x and y, it's moving what? Something up. Okay, so 3 in x and then 5 in y. Similarly, retreat means I'm getting back the what? From the glide to the original position. Okay, so this is the code. Retreat, retreat. If our command is clear, back, back. Okay, did you see that it's moved one step back? Again, I will say back. Okay, so this is only can called as a voice command. So I shown you for the computer vision. Now natural language processing, what we are speaking. We have to use these in our projects. What project you want to, you are going to develop, there you can what combine all these technology, then it will become as a project. Okay, predictive analytics. So AR tutoring app showing the hints. Okay, the VR flight simulators, that and all we can, which one is difficult, we can get that what skill. Okay, predictive analytics and personalization, and then simultaneous localization and mapping. Then we are having the gesture and emotion recognition. Okay, so AR kit hand tracking, excuse me, and then generative AI content creation. Okay, if you what this and all, Adobe Firefly generating AR assets. Okay, we can what try with this. What kind of application we are developed, based on that we can able to use it. Okay, intelligent agents. Pokemon Go is a what it's a game. Okay, the kids were play, and then we are medical training with the AI patient. Okay, nowadays what the doctors and all getting trained with the VR concept itself. Okay, and then data fusion and sensor processing. Okay, edge AI, ethics and safety monitoring, all we can't able to show it on that Unity. Okay, so few I shown to you. software used. So we, as of now, we discussed what is spatial computing, what all the technologies are involved, what is the characteristics of the spatial computing, and then how this AR VR involved in the AI. Okay. So now for this spatial computing, what kind of software has been used? So the kind of software is used is Unity. Another software is also there called Blender. What is the difference between the Unity and the Blender? Okay, Unity has the various types of properties. Packages, so and so. The blender means the blender which is used to create the models. Okay, create the 3D models. Okay, you can sculpting. Okay, your own model that is available in the blender. Okay, so what is Unity? Unity is a game engine used for making games, VR, AR simulations app. Blender is a 3D content creation tool. Okay, you can create your own modeling, sculpting, animation, and then the rendering. Okay, so we can focus on builds interactive experiences, games, VR, AR app, focus on the real-time rendering, handling the physics, scripting, UI, input, multi-layer. Here we are having the 3D assets. Assets means some models are there, textures are there. Okay, model means the cheetah. First video I showed you that what are all the things you saw in that video. Everything is a model. Okay, let us say I hope the first model you saw the dinosaurs, then you saw the cheetah, dolphin. Okay, so these are all the 3D models. It is not a real. It is not a real. The human, elevator, everything is a real. The kids are real. Okay, but what we, along with that, we saw the models too. Okay, dinosaurs, dolphin, and then cheetah. I didn't fully play that video. What until what I shown you, that only I am saying now. Okay, texture means, okay, let us consider cup is there. Okay, some vessel is there. If you want to give the golden texture, yes, you can. Okay, otherwise, if you want to give the silver texture, yes, you can give. If you want to give the platinum texture, you can give. Not only the what gold, silver, platinum, and also for mountain, if you want to snowy mountain, yes, or like desert mountain, completely only rock without any single grass, yes. Otherwise, completely you can the mountain is covered with plants and trees, yes, that only can called as a textures. Okay, animation, this and all we can do. Okay, rendering. Okay, in Unity we are having the head mounted display, so we can see the quick response in it, but the blender is a what, offline only. Okay, so here we are having 60 frame per second, FPS, frame per second in a mobile game. Here, a 40K movie frame may take a minutes or hours. So one example is given as a VR museum where the user walk around. Just before I show you the Taj Mahal 360-degree view. Okay, virtual walk is completely different. Just I am showing, telling what we saw is the AR. Okay, and then here the blender, we can sculpt the dinosaur model. The blender handles the sculpting, texturing, and then the animating. Here what you are creating, the 3D model, that you can import it on the Unity. Okay, create a 3D model in Blender, anything, whatever you want, and then export it. Okay, the extension is OBJ file. It has been accepted by the Unity, and then you have to import it for the further purpose. Okay, so this is the Unity. Now you should know there are various things on the screen. In the upper, what we see is the file menu. Okay, if it is a PPT presentation or Google Word document or what, everywhere we know that there is a file menu, and then the left hand side portion can called as a hierarchy, and then on the right hand side portion can called as a inspector. Then at the bottom we are having the project window, and then next we are having the asset window. So this is in the Unity screen. You should know left hand side is the hierarchy, right hand side is the inspector, and then middle is the scene, and then at the bottom you are having the project window that only listed here. These are all called as a editor component. Scene view, where it is in the middle place. Hierarchy window, it's in the left hand side. Project window, it is at the bottom. You can see here project window, it is at the bottom, and then inspector window, it is at the right hand side. Toolbar, okay, it's okay. I will show you the toolbar. This is the toolbar. Bottom of the menu bar, we are having the toolbar. Okay, hand tool, move tool, and then we are having the rotate, and then we are having the scale. Okay, these are all the toolbar. Then console. Console means here in Unity we are using the C# coding, and then if any mistake if we did, then it will show the errors warnings, and then we have to bug. Then what are all the components of the, this is the, excuse me, this is the editor component, and this is the engine component. So game object, just before I shown you the cube is a game object. Okay, whatever we are keeping inside the scene window, that can called as a game object. Okay, so there you can see that by defaultly we are having the directional light, it is a game object. Camera is there, it is a game object. Other than that, we are adding cube. Okay, I will show you one second. Let us consider this itself. Right click, when you right click, and then 3D object. I will do it here. Sorry. Okay. If I click, that object is selecting. Okay, so cube, sphere, capsule, cylinder, plane, everything is a game object. Okay. And then component, behavior or properties that you attach to the game object. Transforms, ridge body, collider, script, these are all called as a component. Okay, I will show one example. Okay. New project, and then you can select the core, then 3D core, then ball game, or we can tap it. You can see here it is in D: project, and then the ball game. Okay, if you can go here and then select the layout as a default, then you can get a default. Okay, so as I said earlier, the left hand side portion is the hierarchy, the right hand side portion is the inspector, and then what this is the project window, and then here we are having the asset, and then this is the console. If we do any mistake, and then the error will shown here. One second. Excuse me. Just 1 minute. Yeah, now the project has been opened. Just okay. It's not coming. 1 second. Okay. Okay, now what we are going to do, we are, as I said earlier, main camera is there, direction light is there. Now right click and then create the object sphere. Okay, we need one sphere and then you can name it as a ball. Then we need one plane. Okay, we can make it as a plane. Okay, and then we can lift the ball little bit up. Then if I want to color this ball, okay, so how can I give? Right click in the project window. Look at here at the bottom, we are having the project window. Right click on the project window, create material. Material. Material, we can give us a what? Sphere material. Okay, so I named it, it is a sphere material. By clicking here, then any color if you want to choose, you can choose it. And then now the color, as you have to drag and drop to the which object you want to color it. Okay, now the ball turned to red color. For the plane, if you want, you can give the another material, create, and then give the material green. Okay, material. So now I am picking the color from the inspector. You can see here, selecting the right click, create, and then the material. Then now I got a material. By clicking that in the inspector window, right click here, then you can get the color. Now if you place this into the plane, now what? It turned into green color. Now what we are going to do? We are going to right click, create. At the bottom, you are having the physics material. Okay, so I added the physics material. Now in that, the bounciness is there. I am changing that bounciness into 1. Okay, and then the friction combined, bounce combined, I am changing into maximum. Okay, now I am assigning this what bounce physics material to the ball, and then and also I am going to add the component ridge body. What the ridge body will do? Ridge body will give the gravity to the component. Okay, so by done this, we can see now what is happening. Okay, the same way you can create sprites, and then if the ball hit the base, then you can make it as a score. Okay, only two components, two objects has been used. One is a sphere that has been named as a ball. Another one has been plane. The object itself plane, and then just colored it. And then in the add component, okay, rigid body has been added. And then from the project window, right click, create, and then the physics material. So this physics material bounciness, you can see here, bounciness has been changed, and then the bounce and then friction has been set into the maximum. This way we can what do. Okay, so this is only I want to show physics engine. Okay, scripting in the voice movement itself, I shown you the scripting. Scripting means coding. Okay, so there we are using the C# scripts like Python or Java. There are various packages, default packages are available in the we have to choose that what kind of packages we are looking for. Based on our work, we can choose our own packages. Okay, so this is the C# script control behavior and logic. Lots and lots of packages are available. Physics engine, rigid body. Now I added the gravity to the ball. Rigid body, collider. There are various types of collider. Box collider is there. Box collider means for the cube we can fix the, for regular regular shape we can use the box collider. For irregular shape we can use the mesh collider. And then we are having the sphere collider. Okay, there are various types of collider. What is the use of the collider? When two objects, when one object hit the another object, or to detect, okay, that time what should happen. Okay, let us consider the man is walking closer to the door. Okay, and then we can see that the door will be automatically opened. Okay, that one we can call as a, it means what, here there is a object, person, another object is the door. Okay, and then collide means when the human object, okay, let us consider mesh collider, clash with the door object means box collider. Then the trigger happened. What is the trigger? The door has been automatically opened. Joints. Okay, rendering engine, materials, shaders, lighting. Okay, how in real life when you go for the hotel, okay, the restroom lights and all auto switch on as well as the auto switch off. Okay, based on the sensor it is emitting, and then it is switch off. Okay, so cameras, post processing, so these are all comes under the rendering engine. UI systems means user interface. Okay, we can use that text, and then button, canvas, that and all you can use, we can use it. Animator. Okay, we can create our own animations. It is possible in the Unity. So the runtime components are input system, audio system, nav mesh, networking, and then the build system. Nav mesh means path finding, and then the AI agents. I will show one demo for this. So you can see here it is a nav mesh. Nav mesh means path finding and then the AI agents. Okay, so there should be some, there should be some source, and then there should be some destination. Okay, so you can see here in this project. Okay, this is the example of the navigation. Okay, so one floor is there, this is the floor, and then one cylinder is there, this is the cylinder, lavender color is the cylinder, and then one cube is there, this is the obstacle. Okay, and then the game object. Game object means here we are setting the position where the cylinder should reach. The position is, you can see here, 0 minus 9.99 in y direction, 1.5 in z direction, 14.1. This is the destination the game the cylinder should reach. Okay, that this point has been set on the game object. Okay, now I will show you. You can see here this project. the cylinder is started moving from the source and then it is reaching some obstacle. Okay, after reaching the obstacle, but the destination is somewhere. So what is happened? It turn, it take right, and then what? Take right, and then it reaching the destination where we set the position. Okay, you can see here the cube, the cylinder is actually in the. Okay, I will stop. You can see here the cylinder is in the position of 0, 0, 0. But where it reached the game object position somewhere. In between, we are having the what? While going -9, the game object, the destination is -9, 1.5, 14.1. Here the cube is obstacle, it is crossing in between -7. Okay. So the cylinder is taking, again, once again, I will execute that. So from the initial point, it is reaching that 7.5 and then it met the obstacle and then it is reaching to the destination. Okay, this is written in the coding. Okay, so you can, now we can see the code. Okay, so what concept we are using? We are using the AI concept. Okay, and then nav mesh agent, navigation mesh agent is the player navigation. The cylinder only what playing the navigation. Okay, the agent is there, name mesh agent is there, the game object. I told you, no, the position what we are setting is the game object. Okay, the position is the new point I given that. So what is happening? The nav agent is helping the cylinder to reach the position. So the position, the new position, transform the position. So update means in the C# code we are having 3 sections. Okay, look at here. Okay, under the mode of behavior there are 3 methods are there. One is a awake, another one is a start, another one is a update. Okay, in the execution of the program itself, anything should happen. If you want to do, means then you have to give it in the start. After the program has been started, anything should happen means you have to give it in the update. Okay, so here what? The nav agent made that some obstacle means then what? The awake has been takes place. It is not stuck. Okay, you can see here how we have to do it is in the window we are having the AI. In the AI we are having the navigation. Again I will show you. In the top layer we are having the window, in that AI, in that navigation. I already clicked, that's why I didn't click now. If you click like this means then you will get like this. The new tab is added next to the inspector. Okay, in that we are having the agent, areas, bake, and then the object. Okay, so what we have to do is in the bake we have to give the for the floor we have to give the bake. Then only any object can move smoothly on the surface. You saw that how the cylinder is softly moving on the surface. For that we are giving the bake. Okay. Okay. Okay, networking build system. Okay, so these are all the runtime component. So you just got an idea of what happens when your game runs. For that we saw one example for the pathfinding, and AI agents. Okay, so physics in Unity. Just before I shown you that ridge body collider. Collider means, okay, I will show this. Ridge body. Okay, in the Unity itself, we are having two things. One is a 2D game is also there. Another one is a 3D game is also there. So how it has been called in 2D, how it has been called in 3D. Ridge body is there. If you choose in the 2D core means, okay. See, when I click the new project, I didn't give new project, don't afraid. Okay, when we click the new project, in the all you can see that along with the template, we are having 2D, 3D, and then high definition 3D, then 3D samples in 3D mobile, VR, AR. For AR, we are having separate. For VR, we are having the separate thing. And then first person, third person, we are having separate. What project you are going to develop, based on that you have to choose. By choosing the 2D, if you are planning 3D, it's wrong. By choosing the 3D and then you are trying to look up the 2D properties means it is completely wrong. So you should aware of that, what is your work, what you are going to do. So if you click the only core, I want to go with the core means, then we are having the same similarly 2D project as well as the 3D project you can create. Now come back to the class that. So you can see that in 2D component, the same can called as a component can called as a ridge body 2D, but in 3D it can called as a what, ridge body 1D. Colliders, I told you, no, box collider is there for the box space, for the shape, box shape, and then sphere collider for the sphere shape, and then mesh collider for the irregular shape. Excuse me. And then in the 2D component, we are having the box collider for the 2D and then circle collider for the 2D. Okay, joints. Joints means, okay, door is there. Along with the door, frame is there. If you want to connect that door and frame means that time we can apply the joints. Okay, you can see here, connect objects with physical constraints. Okay, based on that you can join it. Okay, so there are some type of joint, hinge joint, spring joint, so and so. Okay, and then physics material. Just before I show you the physics material, the bounciness. Okay, that we can call as a physics material. Gravity. Okay, in the rigid body we are having the option called gravity. By giving the gravity only, the sphere is fallen from the space to the floor. Okay, ray casting. Ray casting means like when we are applying any what, the laser light means, then that can called as a ray casting. Okay, so this is for the collider. You can see that make a cube fall on a plane and collide. So this way, okay, nowadays you people are very blessed that you are having a chat GPT. Okay, when I am started that time in 2021, that time there is no chat GPT and all. Okay, so how I learned this, I have to watch the YouTubes. Okay, from the YouTubes, have to watch several hours, has to supposed to spend to watch the videos, and then the truth is the content provider won't give all kind of content. Okay, they supposed to subscribe or they supposed to pay for it, even though it may not be clear, so and so. But nowadays you are having a chat GPT. If you have any thought to work on some kind of project, it will give that overall frame. Okay, how can you draft your project like that? From that, based on your creativity, you can create your own project. Okay, so this is the okay, I will show you. Just collide means what? Here you can, okay, try to understand this, then you can do it by yourself with the help of the code. Okay, so you have to open the Unity, create a new 3D project, and then in the hierarchy, right click, and then you have to choose the plane. Okay, just before I shown you that ball tapping. Plane is a 3D object. There is an object called plane, and then right click the 3D object and then choose. So here now two objects we were chosen. One is a what? One is a plane, another one is a cube. Okay, another one is a cube. Now what we have to do? Add the ridge body. So by selecting the cube, this is the cube, this is the cube, then you have to select it in the inspector, add component, add the ridge body. Okay, so the ridge body has the property of the what? Cube fall, that is the gravity. Now you have to check by defaultly for the plane we are having the mesh collider, and then the cube we are having the box collider. Now what will happen? The cube will lay on the plane. Okay, we set the box collider and mesh collider, it just lay on the plane. If we set the what gravity, means what will happen? It pass through the, okay, I will show this 1 second quickly. I will show this. Okay, let us consider. Okay, what they said, instead of, okay, I just remove this property alone. Physical, okay. Now we are having the ball and then the sphere. So if it is a ball, you can see here in the right hand side, sphere collider is there, and then ridge body is there, gravity is there. If it is the plane, means what? Mesh render is there defaultly. Okay. Now if you play, means what will happen? The ball just fallen and place on the plane. That's it. This is only can called as a collider. It means what? We didn't give any command for the trigger. If we give something, okay, I told you, the man stand in front of the door, means if I give any command for the trigger, open the door, means then only the door will be open. Unless we didn't give any command, nothing will happen. Okay, this is only they mentioned here. Just instead of cube, I shown you the what? Sphere falls on the plane. Okay, so there are here, as of now, the color is the material. Okay, 1 second. Okay, this color is the material. Okay, right click, create, and then you can see here material. Color is the material. Not only that, apart from that, there are various materials are there. Okay, various textures are there. Something is completely free, something is completely price for it. You can see here this CG let us, you can remember like this, computer graphics bookcase. Okay, there are free PRB textures, metals, wood, stone, fabric. So these are all we are having. Okay, so there are various websites are there. By defaultly Unity Asset Store is there. I will show that alone. Okay, so you have to go to the window. In that window, here you can see that asset store. Again, I will show you. Go to the window, and then in the window you can click on the asset store. Then it will take you to the website Unity Asset. Search online. Okay, so here you can get the 3D, 2D models, audio, whatever you want. You can take import anything from here to your Unity window. So here it shows the what $5, $2. Something is a what payable. Some things are what free of cost. Okay, so it will take time. Instead, I just show you which is already downloaded in my work. So for that, how can we go? Go to the window and then package manager. Okay, it will fetch the packages. We will come back and then the what 3D models, from where we can download the 3D models means again from the Unity Asset Store we can download. Sketchfab is there, free 3D is there. Okay, so there are some places are there we can easily download the model. Model is different, texture is different, material is different. Okay, don't confuse with model and material. Okay, material means we can apply on the model, that is material. Model means what? I will show you this Sketchfab. Okay. You can see here. This is the free 3D models. Okay, I just looked upon the jewelry model. So the jewel is here $14. Okay, anything is cost, we don't want that. Okay, if anything is free, you can download it. Okay, so you can see here pearl necklace. Somewhere if you looking for the model, then you have to download as a obj object. Okay, obj, then you can see here download 3D model. Okay, FBX is also allowed. Okay, either FBX or what see, they mentioned that pearl necklace is, this model is free. This is from the Sketchfab. You can see here Sketchfab. This model is free. Okay, so which one we have to download is either FBX, GLTF, anything you can. Now what our well-known version is FBX. I'm just trying to download it. Okay. After downloading, we can import it on the, okay. Not the packages. In projects. Okay. Not in projects, my assets. Stylish astronaut. Okay. Okay. Stylish astronaut. Download. See, this is already I downloaded from the Unity store. So it will be available in the under the window under the package manager. Okay. Now again one new window has been opened called package manager. Again I will repeat, if you want to use any asset means property, anything if you want to use it means, then you can go for the asset store. Okay, then there you have to search and take. These are all the properties already which I used in my projects. Okay, so that's why the downloaded projects are available in the package manager. Where you can find the package manager is under the window, you can see the package manager. So from the package manager, even though I already downloaded long back, I didn't use. That's why it's showing here. So selecting that astronaut, now I'm giving that download. Okay. After downloading, we have to click the import. Okay. Again, if you click the import, again, I want to download the house pack 2 for showing something to you. And just house pack I'm doing. And then I'm importing. I will show the two 3D models, how it has been added into the Unity. Okay, I just close it here. Come to the scene, and then here, stylish astronaut. Okay, the character astronaut. You can see here, the astronaut is here. This is only can called as a stylish astronaut. The demo, just for that later, if you give any movement to the astronaut, then the astronaut will move forward. Okay, I didn't give anything, just it's falling down. I don't know. Did you notice it? Again, I will run for you. Just see here, the astronaut just falling from the sky to. By writing the coding, and then you can give the movement to the astronaut. Okay, and then you can see the what another I chosen, that is a house pack. Okay, and then models, and then house 1. Then by drag and drop the house, this way you can build the house. Okay, this is house 1, and then house 2. You can get the various types of house. You can reduce the size of the house. Later you can move, one house is there and then another house is there. Like this you can what form a street. Okay, already my time is up. Okay, just I'm showing. So first you have to make it, and then you can keep the houses. You can create your own villa. Okay, by the creativity, and then you can see my houses are not in front of the camera. That's why it's showing there. You have to adjust, and then either you have to adjust the what houses, or you can adjust the camera. Okay, how to. Okay, just we can check once whether it is. If you reduce the size of the house, then you can able to visible. Just I will look 1 second. Okay, you can see here. Okay, the house, one of the house, we can able to see the back side of the house. Okay, so this is only the design techniques. This and all based on your project, you can use it. Okay, so this is I want to show. There are 2 NPTEL courses are there. Okay, currently I am pursuing one course, that is mobile virtual reality and artificial intelligence. Really, this is a nice course. What I am enjoying in learning. This is only 4 weeks course. Okay, I think this semester is over. In the upcoming semester, you can register and learn. And then another course is there, Foundation of Virtual Reality by the Manivannan sir. And then what this is also they are giving the deep knowledge about the VR concept. And then the best AI tool what I felt for learning the AR VR concept is the ChatGPT. Okay, thank you very much for your patience till 9 o'clock. You will learning. Thank you and God bless you all. If you are having any queries, you can ask now.
Thank you, ma'am, for your presentation. Participants can now ask any questions. So participants, please note the feedback form is given in the chat box. You may please fill it. Any questions? Okay, and then I invite Jasmine Joseph, Assistant Professor, for the vote of thanks.
So once again, good evening everyone. On behalf of Nirmala College Muattura, Department of Computer Science and all the participants, it is my distinct honor to deliver this vote of thanks. I would like to extend our profound gratitude to Dr. Shantashila ma'am for her enlightening and relevant section on Introduction to Spatial Computing and its applications. Your expertise has opened our eyes to a whole new dimension of technology and its vast potential. The live demonstrations made the session more engaging and interesting. Once again, thank you, ma'am, for sharing your valuable time and knowledge with us today. Also, I am taking this opportunity to thank all the participants who stayed till the end of day 2. Thank you.
Thank you, Jaswin sir. Once again, thank you, Shantashila ma'am.
Thank you, Elizabeth. Thank you, ma'am. Thank you, sir. Thank you all.
Okay. As we come to the end of today's FTP session, let us reflect on the key takeaways we gained and the valuable insights. Once again, thank you so much. Good night.
Thank you, ma'am.
Thank you so much, sir. Thank you, ma'am.